So in this lattice method, we are going to, like in the box method, we're going to give each part of these numbers their own box, but we are going to treat them like single-digit numbers each time. When we multiply the 6 and the 5, we're going to write 30 here. But we're going to do it in a way that keeps the ones place separate from the tens place. When we multiply the 6 times the 30, we're still going to get 6 times 3, 18. But we're going to do it in a way that keeps this 180 by putting this in a special diagonal column that makes kind of a lattice pattern, the way sometimes a fence will be made with a lattice pattern, so that diagonally there's going to be place value columns. These are the ones right here, the tens going right here, the hundreds going here, and the thousands right here. So the next step for us is going to be to multiply the 40 times 30. We can actually do this in any order that we want. 4 times 3 is 12. That's really 1200. 1, 2, 1200. And then we're going to do the 40 times 5, which is 20 with 2 zeros. I'm sorry. Did I get that right? 20 with 1 0. There we go. So it's 200. So at the end of all this, the lattice diagonal place values, these diagonal columns, I guess you could call them, keeps track of where all the place values should be. So we got a 0 in that ones column. We've got 11 in the tens column. Oh, let me write these normally. We carry the 1 because we got 11 over there. 6 there, 1 there. So our number altogether is 1,610. Same number we got with all the others. If you estimate first, you can check to make sure that it fits your estimate. But this does a nice job of keeping all the work that we did in the box method organized in one place, so the addition is set up just as easy as in the standard algorithm. I think this is a really nice combination of everything, and it keeps the multiplication with fewer zeros to keep track of as well. Anyway, however you do it, it's important to get it right. And that's probably more important than being efficient about it. So here's a practice problem that you can try. You can pause it partway through, and I'll show you the answer. How about 57 times 64? Go ahead, pause it, give it a try with any type that you like, any method you like. All right, assuming you've tried it, I'm going to do the lattice method one more time just to show that maybe a little bit smoother than I did before. 57 times 64. And keep it in a pretty tight space this time, I guess. I'll switch colors just so you can keep track. And I'm going to set up these boxes with the lattice ahead of time. And then I'll do my work. 7 times 6 is 42. As I said, we just need to make sure we multiply every number by, in this 57, by every number in 64. 28, so the 20s are there. 5 times 6 is 30. And 5 times 4 is 20. we have these all in their place values. When we multiplied the ones by the ones, we got an 8 in there. 4, 6, and 3. So our final answer should be 3648. 3,648. Cool. If we want to check it with another strategy, 57 times 64. Let's see, we got 28 plus 200 is 50 times 4. Then 7 times 60 is 420. And 50 times 60 is 330 with 2 zeros. 3,000. 8, 4, 6, 3. Interesting. Keeps all those place values just where they should be. Whoops, whoops, whoops. And they're arranged that way for lattice. Oh, I'm starting to come around on the lattice method. All right. Thank you very much for watching. And as long as you get it right, for right now, that's all that matters. Thanks for watching.